Differentiability of a function at x equals a. A function f is differentiable at point x equals to a if the derivative f prime a, which is limit when x approaches a, exists. And you need to use the formula of first principle at a point. Okay, so in addition, we need to check that limit x approaches a from left must be equals to limit x approaches a from right. If a function is differentiable at a point, then automatically the function will be continuous. However, a function may be continuous but not differentiable. Okay, this happens at a point where there are corners or vertical tangents. So you can look at the given diagrams. For this case, we have a corner at x equals to a, and for this case, this is a vertical tangent. Okay, the slope have different limits from left and right. Therefore, the function is not differentiable at x equals to a. Now, we go to example number 5 on page 5. Discuss the function is continuous but not differentiable at x equals to a. For continuity, okay, you need to remember the three conditions. First, fa exists. Second, limit x approaches a exists. And for this case, we need to consider limit fx as x approaches a from right, a positive, must be equals to limit fx as x approaches a from left, a negative. And third, we compare the first and second conditions. fa equals to limit x approaches a. Okay, so these are the conditions need to be satisfied so that your function is continuous. Okay, we go to the first part. We want to check the continuity of the function. For this case, x equals to 1, a equals to 1. So, first condition, find fa. fa for this case is f1. So, look at 1. We have equals here, meaning that 1 is inside this function. So, we substitute 1 into the upper function. So, we have 1 squared plus 3 equals 4. Okay, condition number 2. We have limit x approaches 1 positive first. And for 1 positive, we will use the second function, x plus 3. So we have x plus 3 here. We substitute 1 inside, so we will get 1 plus 3 equals 4. And for limit x approaches 1 from left, we will use x squared plus 3 equals to 1 squared plus 3 equals 4. And from the calculations here, we can say that limit fx as x approaches 1 positive is equals to limit fx as x approaches 1 negative. Therefore, In general, limit fx as x approaches 1 in general exists and equals to 4. Okay, now we need to check the third condition. We compare the first and second answer. So we can say that f1 equals limit fx as x approaches 1 equals 4. Therefore, fx is continuous at x equals to 1. Okay, so we have finished the first part, which is to check the continuity of the function. Now, we go to the next one for differentiability. Okay, for differentiability, we need to use first principle formula, which is f prime a equals to limit x approaches a, fx minus fa divided by x minus a. And for this case, a equals 1. So, let us find f1 first. f1 equals to 1 square plus 3 equals 4. And first, we check limit x approaches 1 positive. Okay, for 1 positive, we will use the below function, which is x plus 3. Okay, and formula is fx minus fa minus fa. What is your fa? fa is f1 and f1 is 4 divided by x minus 1. Okay, so this is f prime of 1 positive. Okay, so equals to limit x approaches 1 positive, x minus 1 over x minus 1. So equals limit x approaches 1 positive of 1. So the answer is 1. So we got the answer for differentiability for the derivative of f prime 1 from right. Okay, next, okay, we will try to find f prime of 1 from left. Okay, so we write limit x approaches 1 from left. Okay, the formula, the function is the upper function, which is x squared plus 3 minus fa. What is fa? fa is f1. What is f1? f1 is 4. So we replace here 4 divided by x minus 1. So we have limit x squared minus 1 over x minus 1 as x approaches 1 negative, 1 from left. Okay, so limit x approaches 1 from left, we factorize x squared minus 1, x plus 1, x minus 1 divided by x minus 1. And we can simplify x minus 1, x minus 1. So we have limit of x plus 1 as x approaches 1 negative. So we substitute 1 inside. So we will get 1 plus 1 equals 2. And from the calculation, prime 1 positive from right is 1. But 1 from left is 2. Therefore, we can conclude that the function is not differentiable at x equals to 1. So for this case, for this function, at x equals to 1, the function is continuous, but not differentiable.